All right, so here are the solutions for review number 2 of the quarter exam. Number 1 says, what is the slope of the line perpendicular to the line whose equation is 2/5 x plus y equals -5? First thing we want to do is underline a key term, which is perpendicular. Now, why do we underline perpendicular? Well, when we're working with perpendicular lines, we need to know that their slopes are negative reciprocals of each other. Now, what does that mean? Well, if we have an m, which is our slope, equals some number, let's say our slope is 2. What is the perpendicular slope, or the perpendicular line slope? Well, it's the negative reciprocal. So what's the negative reciprocal of 2? It would be -1/2. And like we said in class, we flip and negate. Okay, so now that we know that, let's try to solve this problem. Well, we see that the equation that we are given of a line is not in the form that we work with. Our form is slope-intercept form, or we know it as y equals mx plus b. Now that equation is not in that form, so until it's in that form, we can't see what our slope truly is. So if I rewrite the equation as 2/5 x plus y equals -5, and I turn it into that slope-intercept form, I have to minus 2/5 x from the left side, and like we learned, whatever we do to the left, we must do to the right, and we get that y is equal to -2/5 x minus 5. Now that our line is in slope-intercept form, we can now see that the slope is -2/5. So I will highlight the slope, or I'll box it in. There is our slope. Now, since the slope of this line is -2/5, what is the slope of the perpendicular line going to be? Well, we must take the negative reciprocal of -2/5. So we will write the slope of the perpendicular line, that's the symbol for perpendicular, is, now what's the negative reciprocal of -2/5? Well, we flip it, we get -5/2, and we negate it. Now, since it's a negative, we have to negate it. So what does a negative become? We circle it so we don't forget, and we negate it, and that becomes a positive. So our answer is 5/2. That's how you find the slope of a line that's perpendicular to a line who has an equation of 2/5 x plus y equals -5. Please, for tomorrow's test, make sure if the question is asking for perpendicular or if the question is asking for parallel. Remember, parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Okay, the second question reads, lines 2x plus 4y equals 2 and 4x equals 2y minus 3 are. We're looking to see if they're parallel, perpendicular, neither parallel nor perpendicular, or if they're the same line. So we did a couple of problems like this in class, but we remember the first step, step number 1, was to what? We needed to turn our equations into slope-intercept form. Now, what is slope-intercept form? Y equals mx plus b. And if we look at our two equations, we can see that they are not in slope-intercept form. So let's write the equations as 2x plus 4y equals 2. Now, how do I turn that into slope-intercept form? Well, we see that the y is by itself. So let's bring over a 2x. So if we minus 2x from one side, we must minus 2x from the other. And we get that 4y equals -2x plus 2. Now, since there's a 4 connected to a y, we need to divide by that 4. We divide the entire thing by the 4. Remember, whatever we do to the left, we have to do to the entire right. And we get that y equals -1/2 x plus 1/2. That is our equation number 1. I will put equation number 2 in a different color. So here's equation number 2. Again, we want it in y equals mx plus b, slope-intercept form. I will rewrite the equation as 4x equals 2y minus 3. We can bring over a 3 from the right side to the left side, and we get 3, and we get 2y equals 4x plus 3. Whatever we do to the left, we must do to the right, or whatever we do to the right, we must do to the left. So to get y by itself, we divide by 2. We divide by 2. And I like to go left to right, so I'll just rewrite this as y equals, well, 4 divided by 2 is 2x. And 3 divided by 2 we can leave as 3/2. So now we have our two equations. Let's look to see what they have in common. Well, we know that the important thing is the slopes. So I will highlight the slopes, and let's choose a different color. Let's choose blue. Okay. I will box both equations' slopes. So here is, that's not going to work. Let me erase that. So I'll box both equations again. Box their slopes. Okay, so here is our slope for equation number 1. And here is our slope for equation number 2. Now, what do they have in common? Well, we can see that 2 and negative 1/2 are negative reciprocals. So, if they're negative reciprocals, we know that these two equations of a line must be perpendicular. So, the answer has to be choice number B. Very quickly, if the equations, let me repeat myself, if the equations were y equals 2x plus 1/2 and y equals 2x plus, let's say, 3/2, what would these be? These two lines would be parallel. Okay, but in this question we can see that the slopes weren't the same, they were different, they were negative reciprocals, therefore these two lines are perpendicular. But just remember we need to know both parallel and perpendicular for tomorrow's test. Alright, so for question number 3, we are given a figure, parallel lines with two transversals, and we see that they are asking what are the measures of angle A, B, and C. So we have to remember some of our definitions in order to answer this question. We could start with angle B. So to find angle B, well, what is angle B? Well, we can see that angle B and we'll say that this is angle E. I want to name the 63-degree angle as angle E. So I'll put E here. And angle E are vertical angles. Now, what do we remember about vertical angles? Well, we remember that vertical angles are congruent. So, angle B would be congruent to angle E. Now, since the measure of angle E, so the measure of angle E equals, we said 63, that must equal the measure of angle B. So, the measure of angle B must equal 63 degrees. So we can write that in. Measure of angle B, we could put 63 degrees right there because they are vertical angles. Okay, so now since angle B is 63 degrees, we can see that what else must be 63 degrees? Well, two ways we can find this out is through either corresponding angles or alternate interior angles. So I'm going to name this angle down here. I'm going to name this angle, what do we have? F. I can name this F. So I'm going to name that F. Okay? Now, either way, we can say that angle E and angle F are corresponding angles. Okay, corresponding angles. And since we know that corresponding angles are congruent, we can say that angle E must be congruent to angle F. Now, you see how I just added E's and F's into the picture? You can do that. Now, on the test, since you may have a time constraint, you don't have to label them. But in your mind, you could be naming or picturing what these angles may be called so that you could remember all of the theorems that we were taught in class. That angle E is congruent to angle F. Therefore, 63 degrees must equal 63 degrees. So we see that angle F must be 63 degrees. So we'll write that in there. So angle F, we can now write 63 degrees. Now what does that do? Well, if angle F is 63 degrees, we can see that F and A form a linear pair. So angle now F and angle A form a linear pair. Now what do we know about linear pairs? Well, we know that linear pairs must equal 180 degrees. So we can say that the measure of angle F plus the measure of angle A must equal 180 degrees. Okay? Since the measure of angle F is 63 degrees, we don't know the measure of angle A, but we know that they both have to equal 100, that both of them, their sum has to equal 180. So now this just becomes a basic algebra problem where we minus 63 degrees from both sides. And we could see that the measure of angle A must equal 180 minus 63. So we can see that the measure of A must be 117 degrees. Alright, so I will write in 117 degrees up here for A, so 117. Alright, and now I'll make sure I box in my answers so we can say consistent. So you can see when you look back at this that we are boxing in the answers. I will also box in that angle B is 63. I'll box in up here. So we are left with one more angle, and that's angle C. Now angle C we can find again through a linear pair, because let's name it G. The 44 degrees I will name angle G, and I can say that the measure of angle G plus the measure of angle C must equal 180 degrees. So the measure of angle G is 44, so 44 degrees plus the measure of angle C equals 180 degrees. Again, a basic algebra problem where we minus 44 from both sides. And we get that the measure of angle C must equal 36 degrees. So the measure of angle C equals 36 degrees. Again, I'll box in that answer. Now, there are other ways to solve this problem. Knowing all the rules of parallel lines cut by a transversal, we would be able to fill out all of the angles that are made from these two transversals. So please make sure we go over all of our rules of corresponding angles, alternate exterior angles, alternate interior angles, and same side interior angles. If we know that, you will be well prepared for the test to answer these types of questions. Alright, and so for the last question, question 4 says, make sure you know how to draw the angle bisector, the segment bisector, and congruent segments. Well, we can see these are all constructions, but which one is which? Well, what I'll do is I'll underline each one, and then I'll square off the picture so you know exactly which one's which. So, for the angle bisector, we will make the angle bisector red. So I'm going to underline angle bisector in red. And which one do you think is the angle bisector? Well, that's it. Which one is bisecting the angle? Well, we have this. What are the important things to realize? Well, you see that there are 3 marks using that compass. There's an original arc, and then from points we can say A and B. So if that was A, and if that was point B, again, those points right there, we would then put the compass there and make another 2 marks to get this intersection point. We would then draw a line from that intersection point to our vertex, which is right there, and that would complete the angle bisector. So make sure you remember exactly what that construction looks like. Alright, the next, we'll do the segment bisector, or the perpendicular bisector. Ooh. Sorry about that. I'll underline it again. And now, which construction do you think that is? Yep. We'll box it off. It's this one right here. And what do we have to remember? We have to remember that if there is a segment bisector, we are bisecting that segment, and that makes AM congruent to MB. And that makes M the midpoint. What do we have to remember? We have to remember that when using that compass, we went a little bit further than the middle. So if M is the middle, here is the middle. Our compass had to be further than the middle. We made a nice arc. We then kept the exact same distance with our compass. We put it at B. We went past M. Obviously, since it's the same distance as it was before, we make a big arc, and where they intersect at point C and point D, we drew a line, and that creates a nice right angle at M, and it makes our segments AM, and we could write it, segment AM, remember segment on top, would be congruent to segment MB. Okay, and the last one, I'll underline in blue and then box a congruent segment. And congruent segment, we know, has the same measure. So I'll just box it. It's right there. Remember how we do that? We put our compass points at P and Q. We keep that same distance, and we make a nice big arc right here. And then we connect the line from R to that arc, and we see that, again, PQ, I'll write it, PQ segment must be congruent to segment RS. So please make sure we remember those 3 constructions. There will be questions on the test about them tomorrow. We must also realize what the construction does to our figure. Okay, we have to remember that for the congruent segment, that those segments are equal in measure. we have to remember for the segment bisector or the perpendicular bisector that again that bisects a larger segment but makes two segments the same measure, congruent. And we have to remember, if we go back to the angle bisector, we have to remember, if I was to write this, let's define the vertex as C. Let me write that in red. If I define this as C, then we would say that angle AC, and let's make this point right here. We'll make any point. We'll make a point right there. We'll name it D. We'll say, oh, let me erase that. I'll make a point right here, D. We can say now, because of the angle bisector, we can say ACD is congruent to what? That's right, angle BCD. Remember, the vertex has to be in the middle. So our vertex is C. I can underline it. Has to be in the middle when naming those angles. So remember, the angle bisector bisects the angles and makes two congruent angles.